Hello, this is Brother Cromer from the Math Department at BYU, Idaho, and I'll be covering Lesson 9, which is dealing for inference for one mean, sigma known or standard deviation known, or this is really the introduction of hypothesis testing, and so the outline will go as follows. First, I'll be discussing a null hypothesis versus alternative hypothesis. Then I'll be covering type 1 and type 2 errors. And then finally, with that background, I'll be covering a how-to for hypothesis test. Testing one mean where the sigma, or the standard deviation, or the population standard deviation, is known. Okay. So first of all, the null hypothesis is that we assume to be true unless we have enough evidence. It's the status quo, and it's equal to the norm of the status quo. Or if we're testing or comparing two means, the null hypothesis is that those means are equal. Two means being from two different populations. Okay. The alternative hypothesis is that another hypothesis to propose if the null hypothesis should be rejected. So it's the alternative to the null. Okay. And there are three examples in terms of dealing with the null hypothesis. Three possible alternatives. First of all, here is a group of null and alternative hypotheses where the alternative hypothesis is that the population mean, is not equal to some value. So this here is what is called a two-sided test. Okay, so say for instance, men's heights in the United States are 70 inches, and a researcher feels like that it's different. It's different than 70 inches, and so the alternative would be is that mean, or the population mean, is not equal to 70 inches. Okay, or it could be another alternative hypothesis where the researcher thinks that the mean is less than some value. Okay, so the researcher thinks that the men's heights are less than 70 inches. So the alternative in this case would be the mu would be less than 70. Okay, or the alternative hypothesis could be where men's heights is greater than 70 inches. A researcher feels that way, and so in this case, the mean for the alternative hypothesis would be mu is greater than 70 inches. Now with this first example here is that this represented a two-sided or two-tailed test, but then the remaining two represented a one-sided or one-tailed test. The second one here was on the left side, and on the third one, the one-sided test was on the right side. Okay. So now here's a couple of examples of null and alternative hypotheses. According to Giving and Volunteering in the U.S. in 2001 edition, the mean charitable contribution per household in the U.S. in 2000 was $1,623. A researcher claims that the level of giving is different since then. So the null hypothesis, the status quo, is that the mean is equal to $1,623. The alternative is that the mean is not equal to 16 and 23 because the researcher thinks that the level of giving is now different. Now another example is according to the Federal Housing Finance Board, the mean price of a single-family home in 2005 was $299,800. A real estate broker believes that because of the recent credit crunch, the mean price has decreased since then. So the null hypothesis, or the status quo, is $299,800, or the mean is equal to $299,800. The alternative, since the real estate broker thinks that the mean price is decreased, is that the alternative is that the mean, or the population mean, is less than $299,800. So now what I want to do is, for the next slide, I want you to, here's a couple of examples, and I want you to stop the video, and I want you to, based on these two examples, list what the null, or determine what the null and alternative hypotheses for each of these are. Okay, so for this first example, the status quo, or the null hypothesis, is that the population mean is equal to $49.91. The alternative hypothesis, since the researcher thinks that the average cell phone bill, or the mean cell phone bill, is different today, this is how we write it out, is that the population mean is not equal to $49.91. Now for the second example, the status quo is that the mean ACT score is 21, or the population mean is 21, and the alternative is that the mean is greater than 21. Okay? So now what I'd like to do is, I'd like to cover is type 1 and type 2 errors. Okay? Now what I'd like to do is go to this grid here, I'll get to the grid, this grid where it explains what a type 1 and a type 2 error is. Now there's two possible errors that we can commit when we're doing a hypothesis test. One is a type 1 error where we reject the null hypothesis when in reality the null hypothesis is true. Or we don't reject the null hypothesis when we do an analysis, when in fact the alternative hypothesis, this should be HA, but the alternative hypothesis is true. Okay, so a couple of notes here. First of all, we never accept the null hypothesis. We either reject it or we don't reject it. Okay. Also, there's probabilities associated with these errors. The first probability, the symbol for this is alpha. And the other definition for the probability of a type 1 error is the level of significance, which would be even more significant, serious pun intended, when we deal with hypothesis testing and doing a hypothesis test for um, when we go through the steps of hypothesis testing. The second type of probability is a probability of a type 2 error, or beta. Now beta was not mentioned in the video, but basically what needs to be understood is that when one of these probabilities go up, the other has to go down. And so you as a researcher have to decide which one has greater consequences. So if a type 1 error has greater consequences, you want to minimize that as much as possible and increase your type 2 error. Okay. Now let's go through in a couple of examples, and you just need to ask yourself which one are you more willing, or which one has greater consequences. For instance, in a trial, there's two different types of errors. There is finding a defendant guilty when in fact the defendant is innocent, or we find the defendant not guilty based on evidence given when the defendant is guilty. So that second example is a type 2 error. So the question you got to ask yourself is which one has greater consequences, a type 1 or a type 2 error? And for people it's different. It may depend also on the crime they committed, or the seriousness of it, or it could be how close to home it is to you in terms of the crime that was committed. Okay. Now here's a couple of other examples here. The one on the left is a little less serious than the one on the right. But for instance, if you say, for instance, you were walking around campus and you saw somebody with footwear and you weren't sure whether or not they were flip-flops or not. So you can have two different types of errors that you could commit. You could conclude that the student, this should say flip-flops, the student was wearing flip-flops when in fact they were not. Or you can conclude that they were not wearing flip-flops when in fact they were. So there was two different types of errors in this case. So if you concluded that they were wearing flip-flops and you approached the person, this may be some consequences here, or maybe they weren't, maybe you concluded they weren't wearing flip-flops when in fact they were, and there could be some consequences here. So you need to decide for yourself which one of these two errors that you are more willing to commit, or which one of these two errors have greater consequences in your mind. The second one is determining side effects, serious side effects or major side effects in a drug. You may conclude that the drug has major side effects based on results, when in fact there is no major side effects, or the alternative is that there's no major side effects when in fact there are major serious side effects. So which one here are you more willing to commit, or which one has greater consequences, a type 1 or a type 2 error? Well, probably greater consequence is that you concluded based on your data that there's no side effects when in fact there are major side effects. Okay, so now for the last slide here for this video is that according to Giving and Volunteering in the U.S. in 2001 edition, the mean charitable contribution per household in the U.S. was 2000 was 1623. A researcher claims that the level of giving is different since then. Suppose that the sample data indicate that the null hypothesis should not be rejected. Also suppose that in fact the alternative hypothesis was correct. What type of error was committed? So stop the video and determine what you think this might be. Well, based on this is that there was a type 2 error that was committed. We didn't reject the null hypothesis when in fact the alternative was true, so a type 2 error was committed. So now with this next problem, take a look at this problem, go through it, and now and then conclude whether a type 1 or a type 2 error was committed. Alright, so the answer to this one is that it was a type 1 error, because in this problem here we rejected the null hypothesis when in fact the alternative is true. So this concludes the first part of the video. There'll be a part 2 video where we'll cover the how-to when it comes to dealing with hypothesis testing.